Namaste and welcome to the course of Design of Machine Elements 1. So in this video, we will try to understand, an attempt is made to try to understand what is this FOS. FOS stands for Factor of Safety and Stress Concentration Factor. Let's try make out with first with the Factor of Safety, FOS. So as we know that in India, whenever the manufacturer says that this particular bike is meant to ride one person can ride this bike, and yes, we know that it's meant to, right? Do we do that? What we do is we want whole family on a bike and to ride on. So don't know when manufacturer says that 1:1 ratio, if that bike or a material will withhold, and for example 1 kg of load, think that one person has 1 kg of load, 1 kg it can withstand, we won't do it. We add in with whole family over the bike. So here the load on that material is more. So if I say that, yes, now here you can carry up one person on one bike, which doesn't satisfy, maybe go with a 3 on one bike. Now just imagine what would be the scenario. The bike may fail and leads to accident, right? So this is what we do. So the question is, what to be done? The answer is factor of safety. Now the factor of safety is one such element or one such concept where it ensures the suitable to carry load. While designing a component, it is necessary to ensure sufficient result strength in the case of an accident. So this is the one which ensures the that suitable carrying capacity of the material. So always, for instance, we always keep this factor of safety as 2:1. If the material whatever we design, we're going to increase that factor of safety as a double. Sometimes even 2.5, sometimes even 3. So this is where we call it as a factor of safety. Now coming to the next part, like it is defined as the ratio of failure stress or a maximum stress to the working or allowable stress. So it's a ratio of failure stress or maximums that you can apply over it over the working or an allowable stress. So this is a definition of it. But FOS for a ductile material will be yield point by allowable. For a brittle, it's an ultimate by allowable. As we know that yield point is one point where the transformation takes place in ductile material. That sends out elasticity region will be transforming into plastic region. So the point at where this yield takes place, that would be a yield point. That's why in a ductile material, the failure is easily analyzed on this yield point. So we consider the yield point as a reference, it is divided by allowable. That would be a factor of safety for a ductile material. When it comes to a brittle material, we can't find yield point easily because you know that directly goes into a plastic region. So there we consider an ultimate point as a failure point. So therefore, FOS for a brittle material would be an ultimate point by allowable. So this is a simple formula relates to factor of safety. So next is stress concentration factor. Now just imagine I had a paper hole, as you could see over here, and I try to pull it on all the way. So you know that wherever the suction is very less at this point, the failure takes place. So that sends out at this point, you can see over that the red mark over here, it represents the maximum stress concentrated over there. So at that point the failure takes place. So whenever the stress is highly concentrated because of the pull or because of that lesser in what you call the material or a geometrical section, there the concentration takes place. So this is a stress concentration factor in a common. So another example would be over here, you can see this. There is a red mark at the neck of that shaft. So there where the concentration takes place. In a similar way, the concentration factor can be reduced by some ways. Like just imagine this is one sheet which has a crack over here, which has a notch over here, and you can say this, whenever there is a stress being flowed over there, the concentration will be more at that point. So how to reduce this? There will be 3 methods of reducing this effect. One is use of multiple notches. As you could see in this sketch, if I go with multiple notches, the stress will be reduced. And next would be a removal of undesired material. As you could see over here, if I could remove this undesirable material, the stress concentration will be reduced. And another method would be drilling of an additional holes. Again, you can see over here, by drilling additional holes, the stress concentration will be reduced. So in this video, we learnt what is this FOS, I mean factor of safety, what is the stress concentration factor, and how to reduce this stress concentration factor. I'll be coming up with more videos in connection with the design of machine elements in the future forthcoming. Thank you.